Okay, are we ready to get started? Week 7. 2 days before the quiz. Can you believe it? And then after the quiz, don't forget when you hand it in, you're on spring break for this class all the way until March 3rd, is that true? Till March 5th, Tuesday, March 5th will be your day back. That's 2 weeks from today. Oh, that's great. All right, any questions about that? About spring break at all? Am I the only one looking forward to it? You are too? All right, the in-class assignment I just handed back. Several of you have something written on there that says missing the mean conversion calculation. Anything you're doing in your mind, like converting the mean, you got to write it down some way or another, somehow on there. And everybody was using a 2 for the mean, but you didn't show how you got the 2. And it should have been, because the mean's being described as 8 potholes per mile, but the question's talking about a quarter-mile stretch of highway, you got to say, oh, a quarter mile is a fourth of a mile, so you got to use a fourth of the mean being described. So 8 divided by 4 means 2. There's the work I'm looking for. Again, you can write on there, write resubmit at the top of your in-class if I hand it back and it says missing that calculation work, and put it on the table up here on your way out, and resubmit it, and you can get, how many days has it been? 5 days. You're getting back, I don't know, what is that, 25, 35, 45, 55. So you're getting back 40% of the 5 points. So if you think it's worth 40% of the 5 points back, then go ahead and write that down and resubmit it right there. As far as the calculation, I just asked you to set it up. The e to the power of -2, because it's got to be the negative mean. 2 to the power of 3 divided by 3 factorial. Now, the second part of the in-class assignment was to set it up to use Excel, which should have been equals Poisson. The first number is a 3. The second number is the mean 2, and the third number is a 0, because this was asking for the probability of 3. It didn't ask for the probability of 3 or more. It didn't ask for the probability for at least 3. It didn't ask for the probability of 3 or less. It just said 3, and that's why we're using a 0 on the end. So there's the in-class assignment that I just handed back. Any questions about this? You didn't have to solve it, so I know some of you went ahead and solved it, but that was great. Next. The homework you just handed in. Let's go to number 1. Again, here's a Poisson question. It was all about you looking at it and saying, what are the 2 numbers I'm going to use, and showing me what the 2 numbers are going to use, especially if the mean had to be converted. But then in the lecture I said, once you set this up, I'm looking for 3 calculations and then an answer. So if you look, I took e to the power of -4, because the mean is -4, which is half of the mean being described. The mean being described was, what is it? Every 4 potholes every 8 miles. I'm sorry, 4 potholes every 8 miles. The question was 3 potholes 8 miles, so I'm sorry, the mean did not have to be converted. It was given to you as 4, so you would use 4. E to the power of -4, 4 to the power of 3 is your numerator. The denominator was 3 factorial. So I took e to the power of -4 and calculated that out. I took 4 to the power of 3, calculated that out, and got 64. And then 3 factorial, which would be 3 times 2 times 1, which would be a 6. So I calculated all 3 calculations there. And that's what I'm looking for. And then from there, I'm just looking for an answer. Now I did another calculation, which would have counted as a calculation. And that's it. So I had 4 calculations there, but all you need is 3. Remember this for the quiz. If there is a manual Poisson question on the quiz, and I want you to think about what the probability of there being a Poisson question on the quiz that you have to manually answer. And then make sure you remember, put 3 calculations, at least 3 calculations for full credit. Especially if you have to convert the mean. That's a big deal. Yes?
So I rounded what I got for e to the 4 places. So
Right, and that's fine. As long as you went 4 places, you're gonna have a slightly different answer than mine.
Okay.
Maybe the 4th digit in is maybe slightly different, but it's all based on how you round it. As long as you round it appropriately and use 4 digits to the right of the decimal, you're gonna be fine. Number 2. Number 2 said, show detailed work calculating the probability of 2 potholes every 4 miles with the same information above. Above was 4 potholes per 8 miles. The question's about 2 potholes for 4 miles. Here's where you had to convert the mean and show me you converted. So, whoop, where's my work for converting the mean? What was the mean here, 2?
It's 2.
Oh, look at, somebody give me points. There, save. Boom. 4 was the description of the mean divided by 2 because we're using half the amount of miles stretch of highway. Instead of 8 miles, we're using 4 miles, which is half. So the mean would be 2. E to the power negative 2, the question's about 2. So you have 2 to the power of 2 and 2 factorial in the denominator. Show 3 calculations. You should have got about 0.2707. Maybe some of you got 06, maybe some of you got 08, right around 07 though, depending on how you rounded going back here. As long as you rounded 4 digits to the right of the decimal, that's the key for this class. We have to go 4 digits because we're heading to where we're gonna have calculations that will be 0.00 something. And if we only were rounding 2 digits, we would have a 0, there'd be no numbers to calculate. So we gotta get used to 4. Number 3, same thing, it was a Poisson manual equation. And did you have to do any converting? Let's read it. Local credit union has an average rate of 3 per half hour during the afternoon. Use the Poisson equation to calculate the probability of 4 customers during a 30-minute period. The question's about 30 minutes. The mean's about a half hour. They're the same thing, just different words. So there was no converting in the mean take place. The mean was given as a rate of 3. So there's one number 3. The question was about how many? 4, so there's the other number. So e to the power of negative 3, 3 to the power of 4, and then what's the last one? 4 factorial. There's 3 calculations. I end up at 0.1680. We were talking about this earlier. You could be at 0.1681 depending on where you rounded, or maybe slightly different than that even, depending on how you rounded. Now, number 4 had A and B. This was all about you using manually the combination and permutation equations, but really it's such an easy calculation. It was really about you recognizing which one to use the combination and which one to use the permutation. I guess off the top of your head, can anyone tell me which one, combination or permutation, you would use if order matters?
Permutation.
Permutation it is. If order matters, that's what you're looking for. Sometimes it'll be described that order matters, sometimes it will be worded differently, and you gotta realize order matters. In that example we did during the lecture, the baseball question, the second part said, okay, now you're selecting 9 players, but as you select the players, the first player you select is the pitcher. The second player you select is first base. That means order of selection mattered. That's how you recognize it. But, you know, I was being real obvious on the homework, and I literally said the words, if order matters. And that was the giveaway for you to hopefully realize to use a permutation instead of a combination. The difference is, in A, the combination, you have that 4 factorial right there being multiplied in the denominator. In the permutation, you don't have that 4 factorial. That's the only difference between these two. The permutation will always be a larger number because when order matters, you're just selecting, changing how you select 2 people out of 9 of them you have to select. It's a whole different solution, so you have a lot more possibilities. That's why the combination is 5 different ways of selecting, what is it? Selecting 4 tellers out of 5 that are showing up. And in the permutation though, there was 120 different ways. So as you can see, it was a much larger number. And so there's the difference. These were easy. What we're gonna learn today is how to use Excel to solve these. All right, and the 2 Excel, one's called Combin, C-O-M-B-I-N. And the permutation one is P-E-R-M-U-T. There are the 2 words. Let's get these out of the way. Why not? Instead of it being the end of the lecture, let's just do them right now. Whoop, hey, oh. And then we'll go to the instructions. Here it is. This is a combination. You have 8 tellers, I don't know, 8 something. Let's say 8 tellers arriving, but you only have 2 stations. And order doesn't matter. You're gonna pick 2 out of those 8. Nothing about the order matters. It would be a combination. So equals C-O-M-B-I-N, parentheses, 8, comma 2. How many you're selecting that you have to select from is the first number, always the larger number. The second number is how many you are selecting, which will always be the smaller number. So 8, 2. You end up with how many? 28 combinations using COMBIN. Now let's pretend this is a permutation. Let me see, I don't know if my example is the same example or not. Yeah, okay, 8 possible items, you have to select 2, but order matters. Selecting the first one and then select the third one is different than selecting the third one and then the first one, because order means something. So even though you've selected the same 2 people, but you select them in different order, those are 2 different possibilities. That's why the number will be much larger. And in this case, equals PERMUT, parenthesis, 8, 2 is still, we're selecting out of 8, 2 out of the 8, but we're doing a permutation because order matters, so in this case we have 56. Because we're only selecting 2, that's why the number isn't huge compared to the first number. But usually that second, the permutation number, is much larger than the combination number because we're usually selecting more than 2 out of 8. Watch what happens if I make this a 5 out of 8. The permutation goes to 6,720, but the combination, 5 out of 8, because order doesn't matter, only goes to 56 instead of 20 something. So let me put it back. You can see the more you're selecting, permutation's a much bigger number. That was 2, and this one is a 2. Go ahead.
What's the same for both?
It's the same formula except you're using the word combination. Yeah. You just equals combination and then equals permutation. The bigger number on the left and the smaller number on the right when you put it in the parentheses. Can everybody solve this using Excel now? We got that out of the way. All right, let's go to this week's instructions. You only have one week, and hang on, where is the instructions? Hang on. Oh, I'm sorry, I forgot your homework Excel. I forgot the Excel part of the homework. Let's do these real quick. Almost forgot. Let's see, what's given to us? Textile manufacturer processes finds that on average 5 flaws occur in 100 yards of material. So there's the average. If it were 200 yards of material, you'd use 10 flaws instead of 5. If it were 50 yards of material, you'd use 2.5 flaws instead of 5. You have to adjust the mean based on the interval being asked for in the question. In A, the question being asked is 4 flaws in 100 yards. 100 yards is the same as the mean, 100 yards, so you don't have to convert the mean at all. So the mean stays at 5, and the question is a 4. So here we go, equals Poisson. The question's asking about 4, comma. The mean is 5, comma. 0 on the end, because the question's not asking about 4 or less. It's not asking for 4 or more. It just says 4. So that's why there's a 0 on the end. So there's the first one. The second one, what's the probability of 3 or less flaws in 100 yards? Again, this is 100 yards. The mean's being described as 100 yards, so there's no reason to adjust the mean. The mean stays at 5, but this is saying 3 or less. So look what you do. 3 is what's being asked about. 5 is the mean, but now there's a 1 instead of a 0 on the end. That's what the or less does. Put a 1 on the end. So now this is calculating the probability for 3, for 2, for 1, and 0, 3 or less, and adding those all up for you with one calculation by putting a 1 on the end. Next, this one says, what's the probability of 4 or more flaws in 100 yards? We're still at 100 yards of material. The mean doesn't have to be adjusted. The mean is going to stay at 5. But here's the weird part. This is why this example's here right now to prepare you for the quiz, because it says 4 or more. Just like binomial, you got to use the opposite of 4 or more in the parentheses. This is discrete data, so the opposite of 4 or more would be 3 or less. So what should be typed here is equals 1 minus Poisson 3, comma 5, comma 1. You're calculating 3 or less, then you're subtracting it from 1 to find the opposite of 3 or less, which would be 4 or more. Did everybody remember that for the homework, to use the opposite in the first number? You did? All right. Because that's usually what separates the A's from the B's on the quiz. Just want to make sure. All right. D now, it has a different interval. Instead of 100 yards of material, it's using 200 yards of material. And so the mean's going to have to change, but the question doesn't change. 8 or less flaws. 8 or less in 200 yards of material. The first number's an 8, that's obvious. But the mean has to change. The mean's being described as 5 per 100 yards, but the question's about 200 yards, that's twice the material. Because you had to multiply the material twice as much to be equivalent to 200 yards, you gotta use twice the mean. So instead of a 5, there should have been a 10 for that middle number. So this is parentheses, 8, comma, 10, comma, 1. That's the conversion. And then the last one, E, a different kind of conversion. The question's about 20 yards. The mean's being described as 100 yards. You gotta convert the mean to 20 yards from 100 yards. 20 yards is a fifth of 100 yards. So you have to divide by 5. So if the mean is 5, you have to divide by 5, use the mean of a 1. The question's about 2 or less, so you put a 2 as your first number. The second number is a 1, because you converted the mean to a 1. And the last number is a 1, because this is 2 or less. So this is calculating it for 2, for 1, and for 0, and adding those all together by putting a 1 on the end. Any questions about the Excel part of the homework? I noticed that last night I started getting a bunch of emails where people were handing in Excel spreadsheets. That was only for week 5's homework that we were allowed to use the Excel spreadsheet. So I hope everybody realized they needed to handwrite the Excel equations. So there should be 5 handwritten equations instead of an Excel spreadsheet. I tried to catch everybody by replying to them, hey, you know, I need these handwritten. We're going back to handwritten, not Excel spreadsheet. So if anybody in here accidentally handed in an Excel spreadsheet and did not handwrite the Excel answers, handwrite them now. You know, get them off of here as quickly as you can. Hand them in by midnight tomorrow, because you can then get, you know, what is it, 75% of those points back you'll lose because you didn't hand in the handwritten ones. You can hand them in through email because if you're gonna be late, why not email them in to make sure they're on time? But they had to be handwritten. For example, this last one had to be equals POISSON parenthesis 2 comma 1 comma 1 parenthesis handwritten on a paper somewhere.
Yeah, I
Okay, good, you knew what I meant, okay, good. I thought that's what you were asking. Anyone else? Everyone get it? So if anybody only handed in the Excel equations on an Excel spreadsheet and I didn't catch it, please handwrite them now and get them in by midnight tomorrow. Just send me a picture by midnight tomorrow. I'm posting the answers to this tonight for the homework you just handed in, right? But I'm also posting, I think tonight or tomorrow at the latest, the homework answers for week 7. Let's look at week 7. Here's why. Week 7 has 2 assignments, a written assignment, and Excel assignment, but it's due never. So, it's not gonna be due, because you know, we're not even gonna be here next Tuesday. We're on spring break. You guys are, where are you, at home on the couch? Oh, work, I forgot, you got jobs. Good for you. We all should have jobs while we're in college, which I did too. But I'd still try to get on the couch. All right, so, you never have to hand them in, but you have a written assignment, you have an Excel assignment. I'm gonna post the answers so you can use them as study for the quiz, either tonight or tomorrow. If for any reason tomorrow anybody noticed that these answers aren't posted, I want you to also take into consideration on quiz 1. If you recall in week 3, we didn't have to hand in the homework. And so some of you didn't do the homework and didn't really, you know, download the answers maybe, because there were several questions on quiz 1 related to that homework assignment we never had to hand in or do. I want you to take that into consideration when it comes to this homework assignment right here, week 7. We don't have to do it, you don't have to hand it in, but you know this is on the quiz in 2 days. So you definitely want to download the answers that are going to be posted either tonight or tomorrow to have them in front of you while you're taking the quiz, because I'm sure they're going to help you. Any questions about that quiz? How many minutes do we have? I don't know, let's just ask it. But you know we don't have the whole hour. It's going to be time. That's your worst enemy, right? How many questions are there? I don't know. I'm sure there's more than 9. What? I'm sure there's more than 9. It has to be. I wrote 9 yesterday, so there's got to be more than that. Oh my God.
How long is it going to be?
It's going to be forever, I think.
What?
When? I'm saying at least an hour and a half. Wait, how long is the class last?
Hour 15.
Oh, we can't even take the quiz. There's not enough time.
How fun.
Yeah, you like that? Oh, shoot. I don't know. I'm thinking there's like 10 questions maybe, 40 minutes.
Come on, 40 minutes.
least 3 multiple choice, I would think, wouldn't you think? Boy, it sounds easy, it'd only be 40 minutes and 10 questions though. It must be, some of these questions must be easy, because that only leaves you 4 minutes a question, doesn't it?
Mm-hmm.
But if we sat here in silence for 4 minutes, you'd go, God, that's a long 4 minutes. Because you just get bored so easy as a human. Our time would go by so slow. You just sat here, dead silence, nobody tried to move for 4 minutes. It would be the longest 4 minutes of your life. So anyway, there's the homework. Doesn't have to be handed in. I want you to just kind of look at it real quick. Here is this it right here? Here is the homework assignment for this week that the answer is not posted. This is not the answer, just the assignment. What I want to point out to you is something on our list today that we got to learn called contingency tables, and what do they look like. This is called a 2x2 table, meaning there's 2 across the top and 2 rows and 2 columns. And so if I said to you, look at what each row represents. Here's a row. I gotta add these up. How many are there? Does it say here? 550. Okay, there's 550 people got surveyed. And they got asked a question. Have you slept on the job? And here's no, and here's yes. But they also were asked, what is your profession? The survey only was IT professionals and government professionals. So whether they're IT or government, and whether they said yes or no, are right here. Here are all 550. So if I said to you, what numbers would you add together to divide by 550? If I said to you, what's the probability we randomly select and it's one of the 550 people, we look at the answers and it says they're an IT professional. It says they're an IT professional. What numbers would you add together and divide by 550? 151. There it is, 151 and 102. Because you're looking at the column for IT professionals. Now, let me state another question. What numbers would you add together and divide by 550? I had to look at how many are surveyed. If I said, hey, we're randomly selecting one person, and they said, yes, I slept on the job.
102 and 108.
There it is, 102 and 108. You're looking at the row, so you don't get confused, right? Now, all right, okay, you get this. I don't want to go further because I'm going to ruin the whole lecture. So let me keep looking. So there's that. But, okay, I'm stopping. The only other part of the homework I wouldn't worry too much about is where you have to decide whether that's a combination or a permutation, and I'll post the answers either tonight or tomorrow, and then give the combination or permutation equation to solve it. And you gotta figure out what the 2 numbers are. Real quick, I'm gonna read one. You have 11 customer service representatives scheduled today, but only 8 telephone call center receiving stations. You decide to randomly select 8 reps out of the 11. You get it? So I'm gonna read this first one. All I wanna know is, would you use combination or permutation for it? How many, again, I gotta read it. How many different ways can you select 8 representatives if order matters? There it is. Okay, the key word, you saw it. If order matters, so you now know to use a permutation on that one. I'll read the next one down, which could it be 2 permutations? Let's read this. How many different ways can you select 8 tellers if order does not matter? Combination. Too easy, right? I won't even do number 2. Homework's already done there. So don't worry so much about the Excel homework, but worry about the written part of today's homework, or that's never due. Look at, there's 7 questions here. I gotta look at number 7 real quick.
Oh, that one's easy.
Okay, it's easy. Number 7, you wanna do it?
Sure.
You ready? Okay, she wants to do number 7. Now hang on. There's a trick to this one, so I wanna make sure. Are you sure?
Yeah.
Okay. What is the probability that a random selected worker has not, oh, that one is easy. Darn.
Yeah.
Yeah, okay. I didn't think it, okay. We're not ruining the lecture yet. Where's my paper? Ah, let's get back on schedule. All right, here we go. I want to refresh your memory on probabilities again. This is, pretend you got this in front of you. You just converted to relative frequency. See in the far right-hand column there? You convert it to relative frequency, and then I said, and by the way, this is that story from last week where we're a tool rental place, and we're thinking about taking some polishers and having them repaired, but we want to know the risk involved because now they won't be there in case customers want to rent them. And we make good money off these polishers by renting them. So my question is, if we have 4 polishers, think of the logic behind what I'm about to ask you, because this is a repeat question from last week actually. we have 4 polishers, but we're gonna take 2 of them and send them off for repair. So today, we'll have not 4 polishers, only 2 polishers. What's the probability we will have to reject a customer who wants to rent a polisher today? What's the probability? I can't hear it.
45.
No, 45. Let me stare at this. I heard it back here. Where's she? Where's you? How did you throw your voice back there? 30 it is. Think about it. You ready? I said we're only sending 2 polishers to be repaired. How many does that leave us? 2, which means 1 customer comes in, wants to rent a polisher, we're not rejecting them. 0 customers come in, we're not rejecting them. 2 customers come in, we're not rejecting them. But if we get a 3rd customer that day, and it has happened in the past, or even a 4th customer, we have to reject them. We won't get that revenue. We've lost opportunity. This is called an opportunity cost, because you lost the opportunity to make the revenue. There's a 30% chance. So what though if we say, okay, that's pretty high chance of losing the opportunity of good revenue. Let's just send 1 of the polishers to be repaired. What's the probability we'll lose revenue? What's the probability we'll lose revenue? We're just sending 1 to be, huh? Very good. Everybody hear her? 5%. Because if we send 1 to be repaired, that leaves us with 3. The only way we're going to lose revenue is if we have to rent a 4th one. A 4th person walks in, and it says the probability of a 4th one being rented is 5%. We're willing to take a 5% chance of losing that revenue by sending 1 there, by not having 4 and only having 3. Because the probability of renting 4, there were only 2 days in the last 40 days, and we're using history to predict the future. So that means there's about a 5% chance of us needing that 4th one to rent today that we just sent to the be repaired. You get it, right? Okay, what's the probability we rent 2 or less today? Hang on, 2 or less. It's just such a big number. There it is. Why are you the only one answering? What's going on with you guys? Is anybody else here? Are we recording this?
She answered too fast. I was trying to add.
Okay, 2 or less. I said, what's the probability we rent 2 or less polishers? So you had to add up the probabilities for 2, for 1, and 0 together, which come to 70%. 45%, 15, and 10%. All right. We're shifting now. That, by the way, is a 1 column, 1, 2, 5 row contingency table. The one on the homework was a 2 by 2. That's a 5 by 1. Here, I'm going back. Come on, I want you to, this is from last week. Remember this? We're going to talk about it so much I put it on the board. Everything on that slide right there. Remember, we have Markley Oil. Let me go back to the story. I want to catch everybody up in case you're asking. We're about to invest a bunch of, I don't know how much money, a bunch of money for 3 months. And we can either go with Markley Oil or we can go with Collins Mining. If we go with Markley Oil, where is it? If we go with Markley Oil, we could either make $10,000 at the end of 3 months, make $5,000, break even, or lose $20,000. At the same time, we're investing in Collins Mining for 3 months, and we're either going to make $8,000 or lose $2,000. Those are the possible outcomes. We're doing them at the same time, so we wanted to see what the combination of outcomes are, and the math on this would be 4 outcomes times 2 outcomes, right? 4 times 2 equals 8 outcomes, and here are all 8 of them. And we assign probabilities to these outcomes. Make 10,000, make 8,000, make 10,000, lose 2,000. Make 5, make 8, lose 2. Break even, make 8, lose 2. Lose 20, make 8, lose 2. Get it? There's the 8 possible outcomes. Does anybody remember what form of probability assignment we used? There were 3 of them I taught you to assign the probabilities to these outcomes. Does anybody remember the name of the type of probability? How we assigned it? What kind? Please.
Classical method?
Say it again.
Was it the classical method?
No, the classical method is one of them though, and I appreciate that because I was going to have to tell you the other one. If we did the classical method, what he just said, we would have to take each one and divide 1 by 8 because there's 8 of them and we want the same probability to go to each one of them evenly. So it'd be 1 divided by 8. Please.
Subjective.
Subjective method means we pulled it out of our butt. Pulled it out of the air, excuse me. Pulled it out of the air. It just means We asked an analyst, we asked, you know, it's just something we just, boom, here we go, hey, everybody agreed 20% on that first one? Okay, there we go. As long as they add up to 100%, because we know one of these are gonna happen. One of these are gonna happen. We thought through debate, through a meeting, through everybody doing a little research, knowing this meeting was gonna take place, we came up with these probabilities that add up to 100% chance. We know one of them are gonna happen. Matter of fact, my question to you is, what's the most likely outcome according to the professionals who came up with these subjective probabilities? Which one? Making how much on Markley, making how much on Collins? Which one?
Making 5,000 on.
Making
Markley,
5,000 on Markley.
and losing 2,000 on.
Losing 2,000 on Collins. We came up with that being the most possible outcome, which would give us an overall of how much money? $3,000 gain. This one right here. 5, -2, 3,000. All right, here it is on the board. I want to continue. I'm leaving it up here for a minute, but we're about to move slides, so you're going to get used to looking at the board to answer these questions. Go ahead, Al.
Can you say again, like, how you said it was the most probably, just look at how many?
Okay, you're saying how did we come up with the probabilities?
No, like, you said it was, you said it was the most, like.
Oh, we just looked there. That's the biggest one. That's how we came up with it. Because it's the biggest probability. That's how we got that. Okay, what's the least likely? Alan, let Alan answer real quick. What's the least likely outcome? Yeah, see, if I'm asking for the least likely, it's the lowest percentage. If I'm asking for the most likely, it'd be that one. There you go. Okay, now, go ahead.
How did we get the outcomes?
How did we get what?
The outcomes?
The outcomes?
Yeah.
We went back here. Hang on a minute, this was last week. Let me just get it real quick. So here's the 4 outcomes for Markley, and there's the 2 outcomes for Collins. That was given to us. We just had to put them together. 10 goes with 8, then 10 goes with -2, then go to the next one. And we put them in order like this. Here's all 8 of them on the right side. But the really tough part is, where did we get these probabilities? Whoops, where are they? Hang on. Where did we get those? Remember, if it's subjective probabilities, I'm giving them to you. I don't expect everybody to make up their own probabilities, because that's all these are made up. But it was done through meetings and stuff. But here they are. Now I'm going to say to you, what's the probability the first investment, called Markley Oil, makes money? Look at all possible outcomes. All I'm asking about is that first investment. What's the probability it makes money? What I want to know is, which numbers are you using? Tell me which numbers to answer that question. Give me the numbers. How many numbers are there you're going to use to answer this question? That the first investment makes money.
10,000.
Four numbers. Give me the numbers.
0.20.
0.20.
0.08.
0.08.
0.16.
0.16. That's an 8, by the way. There you go. 0.16. 0.26. There they are. Everybody looked at that first number and said, these top 4 have the first company making money. The question said, what's the probability out of these 8 outcomes that Markley Oil makes us money? And there's only 4 of them that have that first investment make money. These have Markley Oil either breaking even or losing money, so it can't fit in there. Does that answer the question? Okay, ready, Alan? Well, how many numbers are you going to use out of the 8 to answer the question, what's the probability Collins Mining makes profit, makes money? How many numbers first, before you give them to me? How many do you see?
4.
4 it is, you're right. Give them to me. 0.20 plus. 0.16 plus. 0.10 plus. What is this one? 0.02. There they are. The ones that have the 8s, where the second investment's making money. This is a contingency table that has, it's a 1 by 8. And you're gonna get questions like this. Whatever the table is on your quiz, if you have a question, if you have a contingency table, what are the odds? Don't freak out, because it doesn't look like the ones we're talking about here. You just read the question and apply the logic to it, the same way you're applying the logic right now. Are you ready? First of all, did anybody add these up? Anybody thinks this is easy and add these up? So
First one's
is it 60 what? 60 or 62?
First one should be
Again, let me see. It is 70.
70, yeah.
70.
Second one is 48.
The second one's what? 48? So let's look. Here it is. 20 plus 8 plus 16 plus 26, the same ones you told me when I asked, what's the probability of the first investment, Markley Oil, becoming profitable? The second question was, what's the probability Collins Mining is going to be profitable? You guys gave me the numbers 20, 16, 10, and 2. You said it's 48, and it's 48. There it is, 20, 16, 10, and 2. Exact same way. Okay, You ready? Now here's the deal. We're gonna learn complement of event, the union of two events, the intersection of two events, mutually exclusive events. But you've got to apply what I'm about to teach you to these numbers. Go.
Do the numbers have to add up to 100 though?
These have to add up to 1.0, 100%. Do they add up to 1.0? Did I got one of these wrong? Did I put a number
0.7
wrong?
and 0.48 is.
Wait, let me go back to the picture. Maybe I wrote one of the numbers wrong. 6 plus 2 is 8. What's that say? 12 makes 20, 30, is that 1 and 10 on there? 30 plus, that makes 56, 66, 72, 80, 90, 100. So there, it does add up to 1. So 100%. They have to add up to 100 because we know one of these are going to take place. So they have to add up to 100. I thought maybe I wrote one of the numbers wrong. So now, you ready? Let me explain the key word for union. The word or is the key word you're looking for to represent union. Now here it is. Here are the 8 outcomes. Think about what I'm about to say. What's the probability that Markley Oil or Collins Mining makes money? Hear the or? Hear the or. How many numbers are involved with that? No, not 8. I love it though. 8 would have been a good guess, because I would have thought 8 too. Let me repeat it now.
Is it 2?
What's the, no. What's the probability that Markley Oil or Collins Mining makes money? It doesn't mean they both have to make money at the same time, that one or the other's making money. How many numbers?
6.
6 of them it is. You would use every one of them that at least one of the companies making money. The top one, 0.20. The next one, 0.08. One of the companies are making money, 0.16. One of the companies are making money, 0.26. Let me keep going. The second, here we go. Here's 0.10, but here we go. This one, break even, -2. Neither company's making money. That cannot be used. But then we have this one still making 8 on the second one, so 0.02. But the last one, a loss of 20, a loss of 2, that can't be included. 6 of the 8, this is called a union. When one or the other can happen, that's called a union of 2 events. What's the probability of the union of 2 events? Now I want you to look at something here. This are 2 events. The probability of one event being the union of another event is represented with a U between the 2 event letters. This is called the union of 2 events, the probability. Look at how big that is. We would add all 6 of these numbers, which is equal to, where is it? Hang on. There it is. 0.82. Just adding all 6 of those numbers. Where are they? 0.20, 0.08, 0.16, 0.26, 0.10, 0.02. Because all of those fit the words, what's the probability of either one company or the other making money? All right. Intersection uses the word and, A and D. A and D. Let me put these up here. Where is the intersection? A and D, O-R. There you go. That's how you want to remember them.
What does A and B represent?
I'm sorry? Oh, okay, now, I want you to look at this. I'm going to say what I'm going to say. You tell me how many numbers, how many probabilities that you're going to use to answer this question. What's the probability that Markley Oil and Collins Mining makes a profit? I'm going to add these words to make this easier at the same time. That's called intersection, and there's only 2 of them where that's happening.
0.36.
There's only 2 of them where that's happening, where both are making money at the same time. So I see at the very top, 0.20, because we got one company making 10,000, the other company making 8,000. Not the second one. The third one right here, one company making 5,000, the other company making 8, so 0.16. And that's it. The next one, we have the second company losing money. The first company's breaking even. The first company's breaking even. The first company lost, first company lost. The intersection where they're both making money at the same time. That's the thing. Now, I want to make sure you realize most intersection questions don't say the words at the same time. It will just say, what's the probability Markley Oil's making a profit and Collins Mining's making a profit? The key word there was and, A and D, between them. And here's what it looks like here. Markley Oil profitable and Collins Mining profitable. There's only two of them. Look how it's represented in graphic here. M is Markley Oil, C is Collins Mining, and there's that upside down U right there. Whoop, darn it. There it is, upside down U, that represents intersection, end. Yes.
That one for union?
This one's union, this is just the U between the two event letters, and this upside down U means intersection.
What's the middle part?
Hang on, we're not there yet. We're almost there, yes.
Can you do one with
Can you do one with U in it, another union?
Yeah.
Okay, hang on, let me see. Let me go back, I'm making one up now, let me go to here are all the numbers. You ready? I'm making this up. This is gonna be a made-up union. What's the probability that Markley Oil does not make a profit or Collins Mining does not make a profit? So let me say that again. This would be Markley not a profit and Collins or Collins not a profit. How many numbers do you see? Just two?
It's in 5. It's 6.
There should be a lot because it's either one of them. The word or means union, that only one of them have to not be making a profit. The first one, they're both making a profit. We can't count that one. But this one is not making a profit here. So we can count the 0.08. So here's 0.08. The third one, they're both making a profit. We can't count it. But the fourth one, we have one losing money there, 0.26. And then this one has a break even, not making a profit, 0.10. This one's not making a profit, 0.12. This one's losing, so 0.02, 0.06. There's another example of a union. All I did was change the words to use both of them not making money. One not making money or the other not making money. The word or is why there's so many percentages involved. Now let me make an intersection, ready? What's the probability Markley Oil does not make money and Collins Mining does not make money? Now there's probably only two, I think. No, there's probably more.
No, one.
No, there's only two,
Yeah, 2.
right? Where they both do not make profit. And wouldn't it be right here, break even, lose, so 0.12? And the other one is
Last one.
the last one, losing 20,000, losing 2,000, which is 0.06. There's the intersection of them both not making a profit. So Markley Oil and Collins Mining, A-N-D, that's the difference between O-R and A-N-D. Do we feel like we understand the union intersection, please?
I don't understand line 6 when it says break even. It says 0 and -2, so they're both losing.
Yeah, but it's not making a profit. The question was not making a profit. This is not making a profit if it's break even, and this is not making a profit because it's losing 2,000. So the question said, Markley Oil not making a profit or Collins Mining not making a profit. Is that what you're saying? I don't know what you're looking at. Which one? What slide are you looking at? This one?
Yeah.
That one? And the sixth one down?
Yeah, the one that's 0 and -2.
Yeah, that one right there. Because this is all about Markley Oil not making a profit, this is still not making a profit because it's just break even. That's why it's included in the intersection, because they're both not making a profit. And then here, losing. What you're confusing is a break even you think is not losing money, but it's not saying, yeah, I'll change the words. Let's change the words. What's the probability that both Markley Oil and Collins Mining have a loss? How many numbers are used then?
1.
2.
Just one. There's only one where they have a loss. She's trying to make the point, this isn't a loss, this is a break even. But I didn't say loss before, I said not making a profit. That's why that we could count it. But now I just got done saying, what's the probability Markley Oil and Collins Mining have a loss? And this is the only one where they both have a loss. Everybody with me? Okay. How many numbers would you use if I made it a union? What's the probability Markley Oil doesn't have has a loss, or Collins Mining has a loss? Everybody hear the exact words? How many are you using? One or the other?
5.
I see 5. Okay, ready? Hang on. I'm holding this up here. I want to make sure I remember there's 5. I'm doing a union. What's the probability Markley Oil has a loss or Collins Mining has a loss?
1.
No, or.
5.
Five.
5. One or the other has a loss. There's 1. There's 2. There's 3. There's 4. There's 5. One or the other has a loss. You gotta watch those words. So that way, because I was using the word loss, we couldn't use this one. We couldn't use this one because that's break even. All right, we're almost there. Yeah.
What was the difference between the first one you said and the second one?
The first way I said Markley not making a profit. And we could use this because Markley's not making a profit there.
And that was 5?
Yeah, that would be 6 of them now. We'd have 6 of them if I said Markley not making a profit or Collins Mining not making a profit, there's 6 of them. But the second time I said Markley Oil losing money.
Because you said it 2 times. You said, let me remember that there's 5. And then you said it again. I don't know.
Okay, here there's 6, not
You repeated
making a
it?
profit.
Oh, okay, my bad. You just repeated it. I thought you said something different.
Okay,
Okay, I got it.
all right, hang on, what over here? How did I have 5 over here? This was because this one would have been having a loss. Having a loss would create 5 of them, but saying not profit would have 6 of them. The one that gets canceled out is that 0.8, which is the 10. This would not be part of that one because of the word. All right, what is a complement of an event? Let me get to that. Complement of event, matter of fact, it's just saying it's everything outside of the event being described. If I said to you, let me see, hang on a minute. Markley Oil being profitable, here, 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 and here. These 4, which came to, Markley Oil being profitable came to, hang on, where is it? I was going the wrong way. Okay, here's Markley Oil being profitable, 70%. The complement with that would be all of those where Markley Oil is not profitable, which would be what percent?
3.
30%, the opposite. That's a complement of an event. It's whatever the opposite of the event is. Don't worry about it. I'm not gonna quiz you on that. As well as not the mutual exclusive events either. But union and intersection, you need to know those.
So we
Now-
we don't need to know those? Or?
Yeah, not really.
So when we're, like, answer that, like, we've been saying, like, say, what's the probability of, either not having?
Yeah.
But the answer wouldn't be 5, right? It would be like the probabilities added together.
Showing me the work of what numbers you're using to add together is the answer, yes.
Because that would,
Right? Is that what you're asking?
yeah, that was what
Okay. Now, this addition law, sometimes called the addition rule, says that if you know 3 parts of this, you use algebra to find the 4th. It says, hey, the union of 2 events, whatever these 2 events are, is equal to the probability of one event plus the probability of another event minus the intersection of those 2 events. That's the law. Well, let's check it, all right? I'm gonna make A equal to Markley. Markley profitable. Profitable. Okay? I'm gonna make B Collins Mining profitable. All right. We calculated the probability A. We said, hey, what's the probability Markley Oil is profitable? And we got, whoops, right here, 70%. So right here, this one is 0.70. We also asked the question, hey, what's the probability Collins Mining is profitable? And we got that, whoops, right there, 48%. So this is 0.48. And I don't know, we want to do the intersection or the union. Either one we can do right now, and we can find the other. Let's do the intersection. We said the intersection, where they're both profitable, we said there was only 2 numbers there, right? There was only 2 of them where they're both profitable. It was this one and this one, 16 and 20, 3.36. So let's put 0.36 here. If you add 70% plus 48%, which makes 118%, I think, or 118, minus 36%, does it equal what the union is? Yes or no? Let's see. Here we go. So I'm taking 70 plus 48, 0.70 plus 0.48 equals 1.18, 118%, minus 36, minus 0.36. And it should equal, what was the union? Was it 0.82? Let's take a look. The union of two events, right here, 0.82. Sure enough, it equals 0.82. Everybody get that? I could give you any three parts of those, and you could find the fourth by using algebra, right? Go ahead.
For B, what did you do?
I wrote B is Collins mining.
Okay.
I made the B Collins mining just for this. Go ahead.
How'd you get 36? 0.36?
The intersection, the intersection was Markley Oil profitable and A&D Collins mining profitable at the same time. And we said right here they're both profitable, and right here they're both profitable, but none of these other ones are they both profitable at the same time. So we added 20 plus 16 to get to 36. Go ahead, you had a question.
So if you gave us that, can we solve that?
If I gave you this, three parts of this in a story, hey, the probability of Markley Oil being profitable is 70%. The probability of Collins Mining being profitable is 48%. And the probability of their intersection is 36%. What's the probability of the union of these two events? Get it? Everybody get it?
Now, would it ever give you the union and then you have to?
Absolutely. It could give you any
Intersection?
three parts of this, and you gotta find the fourth. It could give you the union and the intersection and just B, and you gotta find A. Or could give you the union, intersection, and A, you gotta find B. It's a matter of you just setting it up like this and making the unknown the X, and then use algebra. That's all there is to it.
How did you get the 0.70 and the 0.48?
The 0.70 is we said, what's the probability of Markley Oil being profitable? And the only ones that had Markley Oil being profitable are these top four. So we added these four and got 70.
Oh, okay. That makes sense.
And then the second one is 0.48. This one was asking about Collins Mining being profitable, which is wherever the 8 is, these four. And we added those up and got 0.48. So it's the probability of one event plus the probability of the other event minus their intersection equals their union. All right, that's the addition rule. Let's get to the multiplication rule. I don't want to do the multiplication rule. I forgot. We got to do conditional probability and then multiplication rule. You ready? Conditional probability, which leads us to the multiplication rule, because the multiplication rule includes conditional probability. What is conditional probability? You ready? If you're looking at a contingency table, it's gonna you'll recognize a conditional probability because it will say something has happened already. Something's given. Something's taken place. Let's use these 8 numbers again. You ready? Here's an example of conditional probability. Let's assume Markley Oil's profitable. What's the probability? Now I'm not going to finish that. I want you to hear the beginning of that. I was giving you an assumption, something that's hypothetically taken place, and that you should only be looking at the outcomes that fit in that assumption, that given. Let's assume Markley Oil was profitable. Boom, like as if it was past. How many out of these 8 are we looking at this moment?
4.
4 of them. There's only 4 of them where Markley Oil is profitable. These top 4 right here. So my denominator in this question right now, called the conditional probability, is whatever the given is. Whatever, what's the 59?
How long it took you to get here?
Thank you.
Yeah, it's all right.
That's almost, that's like the 3rd time I made it under 60. I haven't had a semester under 63 times. We are having the craziest winter ever. This is less snow than I've ever saw in my life for a winter. Am I the only one noticing this?
Yeah.
You guys are noticing it? I got here in 59 minutes and it's February 20th. That doesn't even make sense. It usually takes me 120 minutes almost, usually. You ready? Given Markley Oil made a profit. You said there's only 4 of them that fit that given. Let's assume Markley Oil made a profit. Whatever the given part is, that's your denominator. In the denominator is going to be 0.20 plus 0.08 plus 0.16 plus 0.26. There's my denominator, which happens to be 0.70. Okay? Given Markley Oil made a profit, what's the probability Collins Mining will make a profit? But listen, you've now been given the numerator part of a conditional probability. The question about the probability is the numerator part of a conditional probability. The word condition is saying that somehow in the question, something is assumed or given or has taken place. That's your denominator. So I'm going to repeat it again. Given Markley Oil made a profit. What's the probability Collins Mining makes a profit? Given Markley Oil makes a profit are these four right here, and these are the only four I can look at now for the numerator. The numerator said, given Markley Oil made a profit, what's the probability Collins Mining makes a profit also? Out of these four, which ones have Collins Mining making a profit? The first one and the
Second one.
no,
Third one.
third one.
Third one, sorry.
So 0.20 plus 0.16, the first one and third one. There's the conditional probability.
Wait,
Let me
there's
repeat
more.
it to you. Ready?
There's more.
Here's one.
What?
It's not just two, it's
What?
more.
It's
No,
asking
no,
for-
no,
it's
no,
asking
no,
for
no, no,
marks
stop,
also.
stop, let me repeat. Hey, hold on. You cannot look at any more than the condition, which only included the top four. The condition said, given Markley Oil made a profit. There's you can only look at the ones where Markley Oil made a profit, which are the top four. Now, out of those top four, then it says, what's the probability Collins Mining? Remember, Markley Oil made a profit already. We can't even look at the ones where Markley Oil didn't make a profit. We could only look at the ones where Markley Oil made a profit. Now, which ones did Collins Mining make a profit?
The first one and the
The
third.
first one and the third one. That's why we can only use those two probabilities for the top. So this ends up being 0.36 over 0.70, which equals blah, blah, blah. Now, I want to write this using letters, so you can see how this, see that A and B with the line in the middle? That's a conditional probability. In this case, A was Markley Oil. Markley Oil was M. Markley making a profit. And C is Collins. Okay? Given Markley Oil, whatever the given is the second letter. So you ready? This is the probability of something M. The given, I said, hey, what's the probability? Given that Markley Oil made a profit, what's the probability Collins Mining makes a profit? The given is the denominator and is on the right side of this. The question then said, what's the probability Collins Mining makes a profit? That's the numerator on the left side. The numerator's on the left. All right, I want to make sure you get this, so I'm going to do a different one. We're now going to do this. I'm going to flip it. Look at that. I wrote it out in a format that you see here in the presentation. M is going to be Markley Oil's profitable. C is going to be Collins Mining's profitable. This is a conditional probability. You see the line between the two of them in the parentheses. So you know the given's on the right. Does anybody want to put the given in words for me? Given that
Collins
Collins is profitable.
profitable.
Given that Collins Mining's profitable, because it's on the right. All right, here we go. Let me get to my denominator. What numbers am I using in the denominator given Collins Mining's profitable? I see 0.20 plus 0.16 I heard plus 0.10 plus 0.02. You grabbed all the ones that had the 8 because it said given Collins Mining. Now listen, this is a conditional probability. The ones you just picked, the 4 of them you just picked that represented Collins Mining being profitable are the only ones that could be included in the numerator now. Only look at those 4 to do the left side of this conditional probability, which is, what's the probability that Markley Oil will be profitable? Now let me put it in a full sentence as if it were on a quiz. Given Collins Mining is profitable, what's the probability Markley Oil will be profitable? So what's in my numerator up here? 0.20 plus
0.08.
0.16. Because we can only look at this one, this one, this one, and this one. That's what our denominator represents. And out of those 4, Markley Oil being profitable also is only the 5 and the 10, not down here. So that's why our numerator is. So this is 0.36, again, what a coincidence. But this time it's 20, 36, 46, 47, 0.48. A little different answer there. Okay. Now we got to put this all together to the multiplication rule. So I'm going to review this. I want to make sure you get this. A conditional probability is where you're being told something has happened or something's been given. Assume something. And then that assumption, that given, is your denominator, and you can only look at those that fit in that given to determine which ones are in your numerator. So I'm going to that second one again. The second one said, given Collins Mining's profitable, and we said, okay, that's the ones with the 8s. We can only look at those 4, and there's the 4 of them for our denominator. Given Collins Mining's profitable, what's the probability that Markley Oil's profitable? We can only look at these 4, and only these 2 here had Markley Oil profitable. So we grab those 2 percentages. That's how we got that conditional probability. All right, you guys are with me. To make sure you're still with me, how are we doing on time? We're getting cutting it close here. To make sure you're still with me, I'm going to read one off your homework. You ready? Look at that table right there. Oh, these have the answers though. Hang on. I'm going to C where you can't see the answer. What is the probability that a customer who is already satisfied with experience? Now look up there and look for satisfied experience. This is a 2 by 2. The rows are satisfied experience, yes or no. The columns are received products on time for the holidays. Some said they did receive it on time, some said they didn't. Some are satisfied, some are not satisfied. It says, what's the probability that a customer who is already satisfied? Give me the numbers in the denominator. Customers that are already satisfied. What are the numbers in the denominator?
1197.
1197 plus
33.
plus 33, is it? Okay, let me check. Yes, 33. Given those who said, yes, I'm satisfied, then it says, with the experience, what's the probability they did not receive the products on time?
33.
What's the parts in the numerator? Did not receive the products on time? 33. There's how you solve that one. All right, let me read it again. The words are tricky. What's the probability that a customer who is already satisfied, customer already satisfied is the 1197 and 33, those who said yes. I'm going to read it again. What's the probability that a randomly chosen customer, what's the probability that a customer who's already satisfied with the experience did not receive the products on time? The numerator is the ones that said no, but you could only look at the 1197 and the 33, those who said yes. That would be the 33. There's how you do it. Want me to do another one? I'm going to do another one. All right, I'm making this one up on the fly. Given that they received their package on time, what's the probability they were not satisfied with the experience? What's the denominator? Given they received it on time, what's the denominator?
127?
What 2 numbers are in the denominator? Given that they received the package on time, 1197 plus what?
127.
127. There it is. Given that they received the package on time, what's the probability they were not satisfied? What's the numerator?
127.
Just the 127, because you can only look at these 2 numbers. And one of them represent those that were not satisfied, which is the 127. You get it? Alan, what?
Do that one more time. Hold on.
What?
Say that one more time.
You need another one? Okay, here we go. Hang on, I'm scrolling down. There's gotta be another one right here. Oh, shoot, there is not. We gotta make one up. All right? Matter of fact, look, I converted this table from numbers to percentages. No different. The math is the same, except you got percentages instead of numbers, that's all.
Solve it, right?
Huh?
We solve it.
Yeah, you're gonna have to finish it, yeah. I mean, the setup's where all the points are, but yeah, you gotta finish these and solve it. But, okay, I'm gonna make one up this time. Here we go. Satisfied, yes and no. Received it on time, yes and no. You ready? What's the probability? Hang on, I gotta erase this. God, you guys, how much time we got here? We have absolutely no time left. Is that true?
Yeah, we only have like 7 minutes left.
6 minutes? Really? Let me look. I wanna make sure I'm not gonna miss anything important here. Yeah, this is it. Multiplication law is the last item. We're gonna miss a life lesson,
What about that
but
one?
you guys don't care. What?
Contingency.
You ready?
I wanna hear the life lesson.
Yeah, consistency table, these are all consistency
Oh,
tables.
okay.
This is a 2 by 2 right here, but I've used percentages instead of numbers. Same numbers, I just converted to percentages. Took each number and divided by the total. You ready? Let's assume, hang on a minute. Given that a customer is not satisfied with the experience, what's the probability they did not receive it on time? So, what's in the denominator?
8.47.
And
8.47 you said, plus
9.53.
9.53, is that what that says?
Yeah.
9.53, there's the denominator. 8.47% plus 9.53%. I said, given that the customer was not satisfied with experience, what's the probability they did not receive it on time? What's the numerator?
9.53.
9.53 is the only thing, percent is the only thing in the numerator, because you can only select out of those that were in the denominator. You cannot look at that 2.2, is that 2.2?
Yeah.
That 2.2 can't even look at it because it wasn't part of the given, it wasn't part of the condition. So you can only look at the one. Everybody see that? You want me to make one more up? Go ahead.
I just had a question on that one. How would you word the story problem for
Which one?
the union and the intersection?
How would I do what here with these?
How would you word the story problem?
How would I word the story problem? If I was asking for the intersection, I'm gonna use Markley Oil and Collins Mining as the example. What's the probability that Markley Oil makes a profit and Collins Mining makes a profit? The word "and" means they're gonna be making it at the same time. You gotta find the ones where they make it at the same time.
No,
That's
I
called
think
it.
she means the addition law. Do you know the addition?
Oh, I thought you were talking about the intersection. Intersection
That
and union.
That whole.
Oh, this whole thing?
Yeah.
Oh, okay, the probability of A is 70%, the probability of B is 48%, the probability of their intersection is 36%. What's the probability of their union? I'm gonna give you 3 of them and you gotta give me the 4th. What about multiplication? Hang on, this is the last part right here. You ready? The conditional probability times the probability of the given. The probability of the given is equal to the intersection of the two events. Oh yeah. Multiplication rule is the last part of this lecture before we walk out of here. We got about 3 minutes. This is it. This is the multiplication rule. But I want to bring it to your attention. This could be backwards. This is given B, what's the probability of A? But it could be given A, what's the probability of B? Whichever one is the given, the right-hand side, it's the probability being multiplied by it. The given A, what's the probability of B? This conditional probability gets multiplied by the probability of A. It equals the intersection. In this one, the probability given B in this conditional probability times the probability of B would give you the intersection. Either one of these, you just got to have the right-hand side lined up with the probability of the individual event. You ready? We're going to do Markley Oil now to prove this. All right. We did a conditional probability and I erased it over here, darn it. Shoot. Let's, I know we had one. Oh, one's on the PowerPoint. Here we go. We did one of these. There it is. Given Markley Oil's profitable, what's the probability Collins Mining's profitable? So the given Markley Oil's profitable, this conditional probability, Markley Oil's the B, given Markley Oil. So what's the probability of Markley Oil? I think that was 0.70. The conditional probability right there, 0.5143, 0.5143. If I multiply 0.5143 times 0.70, it will give me the intersection of these two, which, by the way, the intersection was right here, 0.36. Sure enough, hang on, let me put it back. Is this equal to 0.36? Somebody take a calculator.
Yeah, it is.
0.70 times 0.5143, does it equal the intersection?
Yeah, it is.
So the probability of a conditional times the probability of whichever the given part is will equal the intersection. If I would have flipped this and said, hey, the probability of Collins Mining is the given, I would have to multiply it times the probability of Collins Mining. Instead of 0.70, it would have been whoops, again. It would have been 0.48. Whoop. There it is, 0.48. Instead, this would have been 0.48 if we were using that other conditional probability. We still would have got 0.36 though, it doesn't matter. This multiplication rule works either way.
Would you give us 2 numbers? We'd have to find the third?
I would give you 2 numbers, you'd have to find the third on the multiplication rule, yes. I would say the conditional probability equals this, 0.5143, and the probability of B is 0.70. What's the intersection?
So you're not gonna have, we're not gonna have us do, like figure out the conditional and then make it into the multiplication law.
Not if the multiplication law won't be mixed in with conditional probability, there'll be a question separate. But you should expect a question about conditional probability as well as possibly multiplication law, but 2 separate questions.
Are you gonna tell us if you want it to be like addition or multiplication?
Whether I want it to be what?
No, are you gonna tell us if you want it to be multiplication or
addition?
No, not at all. You gotta determine based on the information I gave you whether whether you should be using the addition or the multiplication. All right, now look, there's a lot of these that came in late. I want you to pick up your stuff. Anybody doing resubmittals, put them in this pile right here. You're trying to get points for that. Get ready for your quiz in 2 days. Turn off the video.